Okay, so fresh off the heels of the previous video, which featured a very troublesome Neotec 2501, we have yet another Neotec 2501. I mentioned at the beginning of the video previously that the owner of these sent me 3 chassis, 2 2501s and one 2515C. So we're going to knock out the 2501s here in quick succession. Now, I learned my lesson the last time. I've always talked about how it's very important to do a thorough examination and visual inspection prior to working on these. And for some reason on the last video, I glossed over 2 very important factors. The R948 resistor was completely missing from the neck board. And then we also had, what was it? Oh, the B plus pot was completely maxed out. So fortunately on these two, on this chassis I should say, on this one, that's not the case. Everything already appears to be okay, but it's also completely original. So I also wanted to mention that I glossed over those factors the last time, and that was a rookie mistake, and it caused me a lot of headache trying to figure out why I had the all red screen and things like that. But we had the resolution problem, which was caused by one of the polycaps over here, which if you haven't seen the video, go back and watch it. It's previous to this one on the channel. So now we have yet another NT-2501 medium res Neotec, and this is completely original. Given a good look over, all the caps are original, flyback's original. It appears to be completely untouched, and I have no idea what's wrong. This was, all 3 of these chassis were sent to me as not working, and I don't have any other information than that. So what we'll do is we'll give it a good visual inspection here on the camera. I've already pretty much done that, and I didn't see anything odd, but we'll go over and look at it again. The remote board is complete, unlike the last one. The vertical hold pot had a busted knob, but the pot was still intact and you could use your thumb and move it still, so it wasn't a big deal. But this one's in much better condition. So the remote board seems to be okay. The harness seems to be okay. I didn't see any cut broken wires from monitors resting on the wires. Sometimes that can damage them and cut them and things like that. The neck board does have all the components. Seat 924 got shoved over a little bit. Probably one of the leg got taken out a little bit there. It's flat again. We have what looks like a replacement 947 at some point in the past, because it's different style than the other ones. Yeah, I mean, someone's replaced what looks like both 946 and 947, because the factory one looks like this with the stripes. These two are different, so not a big deal. As long as they read 2.7 k ohm in circuit, they should be okay regardless. But that resistor was missing last time, and that bit me. That resistor missing caused Q903 and Q902. These 2 transistors got shorted out because this got powered up with that missing resistor on the red circuit and damaged those. We got some rusty pots here. Let's make sure I can move those. Yeah. Alright, other than that, that seems to be okay. Like I say, caps are all original. I don't see any missing color transistors or anything. No damage. Whoa, we've got some really, really bad solder on R947 and 948. But nothing that can't be resolved. Alright, so the main board here, B plus pot is roughly in the middle. I'm sure it's not 125, but it'll be pretty close. Horizontal frequency is not maxed out. X-ray pot seems to be in the right location. I don't see any missing components that are out of the norm. It's relatively clean, a little dirty, a little dusty, but not too bad. Yeah, seems okay visually. I don't see any caps bulging or corrosion or any signs of leakage. Seems all right. Backside. Yeah, this is absolutely untouched. This is exactly as it left the factory. No one's done any reflow or any rework, any rework. And that kind of bodes well for us, because then we don't have to worry about somebody doing something that they shouldn't have and causing more damage, or trying to figure something out from something somebody did, things like that. So, okay, well, it appears to be intact. So because we don't have anything obviously wrong or missing, we can do some quick testing. Let's pull out this leg of R117 and do the light bulb test and verify our power supply is good. And then if that's all good, we can proceed from the rest of it. We'll check the HOT, make sure it's good. And if that's good, then we'll power it up and see if it is in fact not working, or maybe it was misdiagnosed. Yep. So let's pull out, oh, I got to turn the iron on here. And, you know, I probably should, I'm going to cut away and wait about 3-4 minutes for all my test equipment to fire up. I don't like having the desoldering station running while I'm narrating because it's rather loud. So I'm going to stop the video, power everything up, and come back when everything's ready, and we'll pull out 117 and we'll do the light bulb test and verify if our power supply section is good or not. So let's do that. Okay, everything's up and going, so let's see what we can figure out here. First things first, let's remove R117's leg here. There we go. All right, we are out. As we can see here, 117 is out of circuit, so that will remove B+ from the power supply section to the rest of the chassis and isolate it. So now we can test to see if our power supply section is operational. Let's grab our meter and we'll set it to volts DC. And we can take our negative lead and put it right here in this hole. That'll hold it right there. There's a nice convenient little hole right here that you can take your lead and just plunk it right in there. And then we can grab our positive lead here, clip it onto 117, clip it onto our meter. All right, so we're not really worried about what the B+ reads right now because we're only concerned with it reading 125 once everything operates. But it's a good indication to just make sure and see that it actually is operational prior to trying to use the light bulb. So in this instance, we're going to use just another lead here, and we're going to clip. I'm sorry, not going to clip anything. We're going to take our light bulb and tap it to the ground. The negative part of the light bulb will touch to the heat sink there for the vertical IC. Then we'll take this lead and touch the positive part of the light bulb, and it should light up. So what we're hoping to hear, it's going to be hard for you to ascertain the sound with the equipment running over here, but we should hear a click and a little energization noise of the transformer here. Powering up, if you will. You'll hear the transformer make a high-pitched noise, and you'll hear a click from the power supply section if this ends up being operational. If you hear it do nothing, then it's bad. So let's grab our power and plug it in right here. All right, here we go. We're hoping to hear a click and a high energization whine from our transformer. We're hoping to see some reading here for the B+, and we're hoping our light bulb lights up. So here we go. 1, 2, 3. Yes, we heard the click. And if we touch this to the frame and our light bulb, and it lights up. And we're at 121.3. I don't want to adjust it to 125 yet until we actually power up the chassis. But saying those words out loud, I think I am going to adjust this. So let's turn it off and wipe our B+ pot back and forth, back and forth, back and forth. And we'll set it back to about dead center. Now let's see what it reads when we're about dead center. 127, okay. Let's turn it back down a bit. All right. 123, back up a little bit. 123 still. 125.5, we'll live with that. Okay, so we have a functional power supply section, so now we can test our HOT. and make sure that there's nothing going on there. If that works, then I'm tempted to fire this up and see if it works. I mean, all of these were sent to me as not working. Maybe it's a situation where it was just operator error, and that happens. Obviously, he sent me a bunch of parts. I'm going to have to cap this, reflow it, fly back, all that stuff, which we normally do. But for the scope of this video, we're going to at least get it working to a point to where it's operational. Then we'll do the rework and see how it looks afterward, like we always do. But all right, we need to discharge, because right now the filter cap and everything's powered up. It's not powered up, I'm sorry. It's still energized, if you will. So we need to de-energize all that by shorting it out. So here we go. Okay, well, it dissipated on its own. That's good. Or is that even ground? Oh, yeah. Let's hook our lead back up. And yeah, it dissipated. Wow, on its own. Interesting. Maybe I might have discharged it by moving stuff around. I can't say, but normally you get a pop. But anyway, all right. So let's check our HOT. Make sure that's good. If it is, we'll hook it up and see if it works. Because in theory, if the HOT is good and the power supply section is good, it should turn on and work. We know that our B plus is now adjusted, but I don't know if it'll be 125 with an actual full load on it. It may be a little less. So we might have to readjust that, but at least we know the power supply is working. Let's get 117 back in circuit. Okay. There we go. All right. HOT, this guy over here, right there. And we'll put the meter in diode, and we'll go to negative on the collector, and we should have 0.45 voltage drop to the emitter and the base. So we'll go to the emitter first. Uh-oh. Oh, there we go. Bad connection. Okay, 0.425, and here's the base, 0.425. HOT checks out. So let's look for some any possible bad solder joints. Ah, glad we looked. Look at the header pin for the horizontal yoke pin here. That's about as close as I can get. If we look at this guy, we've got a nice big crack around, well, that's vertical, I'm sorry. These two are horizontal, the closer two are vertical. There's a nice big crack around the vertical header pin. As you can see, nice big crack around that header pin. So we're gonna have to reflow that. That might have been an issue, I can't say. Anything else? Let's take a look around here and see if we see anything else obvious. Some type of hair here. I don't know what this is. Get out of there. Okay. Yeah, don't really see anything else obvious. So let's reflow these header pins and turn it on. Cross our fingers. Oh, you know what? We need to look at and reflow some of that stuff on the neck board, because we had some iffy joints on some of those resistors for the color there. So with the cracked header pin on the vertical, it really wouldn't have caused the chassis to be not working. It likely would have just been vertical collapse, but you never know. Okay, so let's check out the neck board here. Yeah, there's some, if we zoom in here, the solder joints on this resistor in particular are really, really iffy. I mean, there's basically nothing there anymore. Then you got this right here. That's not good at all. The other one down here, yep, that one here for this one, that's not any good at all. So let's reflow those, because I don't want to induce anything by powering this up in this condition, which I'm sure it already was before it came to me, but I don't want to run the risk like what happened last time. Okay. Anything else to look at here? Neck socket solder seems okay. Not that it wouldn't cause it to be not operational, but the color transistor here, not too good. That's better. All right. I think that's pretty good. I think we'll live with that. Let's take all of our color pots and set them to center like we normally do. Oh, they're pretty much already centered already, but wipe them around. And the bias ones, gain. So these are bias and those are gain, okay. I always put these around the center position just for a good baseline of color, and we can adjust from that point. But okay, well, I guess that's it. Let's get it on a tube and test it, because all of our indications tell us that it should operate, but we're about to find out. So I'm going to get the tube up here. We'll get this chassis on the test tube. I have an actual dedicated 2501 tube that we used in the last video. So let's get it on that tube and see if it works. Here we go. Alright, so we got the anode, neck, yoke, ground, power, video remote all hooked up, ready to go. I've got the B+ set up here with the meter off of the leg of 117 there to verify that if it does operate, that how close we are to 125. And we can adjust as necessary if need be. For now, we're going to use just the test pattern generator set to medium res, so let's turn it on. And all of our tests indicate that it should work, unless there's something wrong with the flyback, or there's a bad cap, or it's going into shutdown, or who knows what. But everything that we tested should show that it should at least power on and function in some capacity. So that being said, let's turn it on, see if it turns on, and what our B+ is at, and where we're at from that point. So here we go. 1, 2, 3. It does indeed power up. Wow. And we're at 121.4, which I need to adjust that. But I don't see anything on the screen. Do we need to turn up brightness? We do. Look at that! Contrast. We're overly green. This is working right off the bat. Wow, it's not even that bad. H position. I didn't even need to adjust any of the holds. The horizontal, see, this horizontal hold is on here, and on the main chassis you have horizontal frequency. So if we look down here, there's horizontal frequency is right there. A secondary horizontal position is right there, and then the standard horizontal position is on here. So wow, right out of the gate, it works. We need to readjust to 125. So let's see if I can snake in here on that pot and get to 125 here. I can't get it to turn. There we go. 125. Oh, you rat bastard. Oh, look at that. Look at that. Glorious. All right. We are way too green, so is it a... Yeah, we're missing blue. That's why. No blue. Well, is that what they're referring to when they say not working? I don't know, but we are missing blue. Not a big deal. Okay. Well, I'm glad that our testing showed that or vindicated, I should say, that all of our testing showed it should work, and it does. So we're missing blue. So we got to figure out what's going on with that neck board. Is it an issue with the RGB encoder chip? Is it an issue with the transistor? A good way you can tell if the transistor is at fault is if you touch, or I should say, you got to be careful. Obviously, disclaimer, you got to know what you're doing. Make sure you don't touch live components here. But if you feel on the resistors, if they're warm, then the transistor should be functioning. That one was, ooh, that one was hot. This one here is not. This one down here, ooh, that is warm. Yeah, this one here, R947, is not warm at all. So that indicates to me that the transistor is not turning on. Whether it's not turning on because of some other issue or it is open, I can't say, but that resistor is not warm at all. So that is a good indication to tell you that your transistor is not turning on. And that would correspond to our no blue. But that's actually not pretty darn good from right out of the gate. It is out of focus a bit, but we're going to be changing the flyback anyway, so it's not a big deal. Yeah, all right. So let's turn this off, and we'll get it back off the tube, back on the bench, and we'll do our cap kit reflow, get everything done on the main chassis that we need to, and then we'll tackle what we need to do for the neck board to figure out the no blue. So when I come back, we'll have all the rework and everything, reflow and caps and flyback, everything, we'll have all that done, and then we'll be ready to test and inspect and check our neck board for no blue. Alright, slight change of plans here. I was originally going to dive into troubleshooting this no blue issue after I did all the rework on the chassis, and curiosity has gotten the better of me, and I want to know what it is now. I don't want to wait. I want to dive into this and see if we can get this figured out and then do the rework and testing afterward. I'm too curious to know what the problem is. So I got the meter here. We can do some testing. Knowing that the control transistor here is cold as opposed to these two here are warm and this one's cold. R947 is cold. We can pretty much take that as read that the transistor is not turning on. And this one is blue, this one is red, and this one is green. So green, red, blue. So if we turn this over and we go to the green transistor down here, it's going to be hard to get this all in frame, but we've got base, collector, emitter. For the blue, we have base, collector, emitter. For the red, we have base, collector, emitter. So on these particular transistors, the way you test these is you put your meter in diode mode and you put your red lead on the base, and you should have 0.6 voltage drop to the collector. Come on. There you go. So 0.6 voltage drop to the collector and 0.6 voltage drop to the emitter. There we go. 0.671. So now if we go to the blue one, if we go base red and we go to the collector, 0.6 and emitter, shorted. Well, there you go. Imagine that. Now if you look here, our 947 goes to this inductor L904 and then straight to our transistor. So here is that resistor R947, and you can see that it goes straight over here to this leg of this inductor and then right to the emitter of our transistor. So with the transistor shorted, it's not turning on, which would correlate to the resistor not getting hot. So that's a good indication of whether or not, if you're missing a color, but all three of your resistors are getting warm, then it's likely not the transistor. But it still could be. That's just a general quick test to let you know if the transistor is turning on. So let's test our green one here. If we go to base and then we go to collector, 0.6, the emitter, 0.6. And our blue one, base and collector, 0.6, base and emitter, shorted, dead short. Is it 1 ohm? Was that 1 ohm? 0.7 ohms. So now the question is it the transistor that's shorted, or is it something else that's shorted? So we need to remove the transistor from the circuit. So we'll grab our desoldering gun here, and let's just yank this out real quick. May have to use the iron here to help us out. Yeah. Yeah. No big deal though. So let's just heat that up. And okay. That should come out nice and easy now. Just like so. Now it's important to test it out of circuit, and let's find out. Let's go to continuity mode just for a quick test, and dun dun dun, 1 ohm. .7. So now let's test the pads on, we'll just go to continuity, and then we'll test the pads on the actual board here, and emitter and base not shorted. Well, that sums it up. Let's grab a replacement. I've got a donor neck board here with, I've already robbed what looks like a blue one in the past, so let's rob the green one, probably easiest to get to. I don't know why they screw these in like this, but they should put the screws going through from the opposite way with a nut, make it a lot easier on everybody. So now before we take that out, we should probably test it and make sure it's good. If we go, okay, base with the red lead, and then collector 0.6 and 0.6. Alrighty, so that should be a good one. Let's see if we can get this one out of here. And magically, it's out. Just that easy. Okay. Now, I'll set our screw up there, put that back in the pile. Crap, which one is it? I think it's this one. I didn't pay attention. Yep, that's our good one. That's our shorter one. Just so we don't get confused, this is going in the garbage right now. Kerplunk. All right. Now let's clean up these legs a bit to make it easier to get this in there, he says, as he adds more solder to it. Well, let's just do it the old-fashioned way here. Where... Okay. Now, all right, let's get this guy in here. Is it going to fit through there? No. Why do you do this to me? It's always something. Come on. Okay, I think that'll work. If you don't get all this original solder off of here, when you try and put this through, you'll pop the pads off. And that's not obviously ideal. I can't get this. There we go. And we made it. Okay, good. All right. So I gotta line this up here. Okay. The screwdriver here is a bit overkill for this, but we'll make it work. This is like a clown show here. This is I'm making a clown of myself. This shouldn't be giving me that much difficulty. Okay, not too tight, just secure. Alright, so let's now solder this back in. Alright. Not too bad. We lost a little bit of the pad, but not bad. Alright, now let's test it. Red on base, and collector is 0.6. And emitter 0.6. Okay, I think we have it solved here. So now I'll do the full rebuild, and we'll come back and check that out, see how it turned out. Then we'll test it and see what happens. And just like that, all done. Full cap kit, full reflow, new flyback, everything good to go. Everything I normally do is now done. So it's time to get this back on the chassis. I'm sorry, tube. Get this back on the tube and see if I did anything wrong, made any mistakes, anything blows up, something new occurs. We'll find out. Everything should be good, and I'm pretty confident that we have fixed our blue issue. Well, actually this one, I'm just touching that. But actually, I'm pretty confident we fixed our blue problem, or our missing blue, no blue. I got the protector back on the neck board because I'm confident that we won't have to get back into it. And everything else is done. So we're going to have to adjust the flyback because the new flybacks come with the screen pot turned all the way down, so we'll have to turn it up a bit. I haven't done that yet, but we'll do that kind of on the fly, no pun intended. The back side, not too bad. So need to do a little cleanup, but we'll do that after we test it and everything. So yeah, I think we're ready. So let's get it back on a picture tube and turn it on and see if we get blue and kind of make sure nothing else goes wrong and see how the job turns out here. So, okay. All right, let's see how it turns out. All right, all hooked back up, and as before, like I always say, we got anode, neck, yoke, ground, power, video remote, all hooked up, ready to go. Critical 7, and we're using the test pattern generator. If all this checks good and works out, I'll test off camera an actual PCB to make sure everything is in line with that. But for now, we'll just use test pattern generator. So let's turn it on, and yeah, let's find out if we have our blue and if anything blows up, if I did anything wrong, if it all works out. Let's find out. In preparation, I need to get my little screwdriver here. All right, so right now we're going to make sure it just turns on. So 1, 2, 3. It does. Okay, so we're good there. Now let's turn. Ooh, what? Oh, I think the brightness is turned up too high. Let's turn that back off. Brightness all the way down. Contrast all the way down, and oh, nope. The flybacks normally come all the way down, but for some reason this one was turned like to three-quarter drive. Wow. Okay, I don't know if that happened after I took it out of the box. I don't know if that happened from handling. I don't know what happened there, but normally these are shipped with the pot for the screen pot all the way down, but somehow that one must have got tweaked up to about three-quarter there somehow. Okay, well, yeah, on these Neotecs, if you have the brightness up too high, or any of the drive pots for the colors up too high, it'll do that noise and flickering and things like that. So, okay, let's try again. Now let's turn all the way down. Brightness, contrast all the way down. Flyback screen pot all the way down. Let's try again. 1, 2, 3. All right, comes right to life. Okay, so now with brightness, contrast all the way down, let's set the camera up on the tripod here. And okay, yeah, for those of you who think that behind the scenes I test this stuff off camera before I show it, I don't. As soon as I hook it back up after the rework, we test it live here together. So just there's an example. All right, so let's turn the test pattern generator on. Okay, so now let's turn up the screen pot until we get raster lines right about, oh, there we go. Raster lines just go away. All right, now we supplement with brightness. Right about there. Contrast, it's up too high already. Okay, let's try focus. Man, that screen pot is touchy. Here, I'm going to turn this off. I'm going to wipe that screen pot up and down a bit. Okay, brightness and contrast all the way back down. Screen pot down. Let's try again. Okay. Now let's give it a moment to kind of settle. And let's turn it up to, let's go right there. All right, now let's do, what in tarnation is happening there? Is it a remote? Oh, it's a remote board issue. Hang on. I'm going to reseat the connections here on the remote board. Because that flickering brightness was happening when I would wiggle this harness right here on the remote board. All right, take 2 here, take 2. Actually, I think this is take 3. Brightness, contrast down. Okay, now we can barely see the checkerboard pattern there. That's where I want to keep the flyback. And it's not flickering now, so okay. Brightness up to, you can see here that the background is not black. We want to turn it down till the background is black, which is right there. Contrast. There we go. Now I can clearly tell that we have all of our colors. So we have restored our blue. That's good. This is still wonky here. See this? Oh, dang it. Well, let me hold on. I don't want to. Let's turn brightness and contrast back down all the way again. Okay, let me do a little bit more inspection on this. Maybe it's a cold solder joint on the brightness pot, and then I'll come right back. Okay, we're in handheld mode here, because if we turn this around, the connector that I was wiggling was actually this one right here. But I think it was kind of a red herring, because in moving this connector around, I was also moving other wires, and it's actually this connector here that's bad, the one with the 3 pins. And if we look at the back side of a P901, let's check this out. We have a cracked joint right there. This one right here. Right there. I don't know how well I can get in here, but you can see, oh, got too greedy. Yep, that outside joint is cracked right there. So let me reflow that. The other connector here, the P401 that has the connection going up to the other pods there, this one here is suspect as well. Maybe it is this one as well. Alright, well, I don't normally reflow the remote boards, but obviously this one needs it. So let's reflow this, and I'll bet you that'll take care of our problem. Okay, so the remote board has been successfully reflowed. Let's try this again for attempt number 4 here, I should say. Here we go. The flyback should still be adjusted to where it was. We don't need to move it. Okay, so this is with brightness and contrast all the way down again. So let's, all right, so far so good. Let's turn up brightness to about there. Contrast is already, let's go contrast to about there. And now let's adjust our focus. And we should be able to bring this in pretty well here. That looks pretty good. And I can already tell you that we have our blue, so if we go to, there we go. Now let's adjust our vertical size. Bit of a scratchy pot. Vertical position, yeah. Horizontal position functions, yeah. Alright, so now we need to adjust our coil because we're not wide enough. And my adjustment tool is right here. So we're going to adjust our horizontal size by bringing the coil ferrite core out, and there you go. Outstanding. Yep, there you have it. So, yep, and our remote board wiggled around. No flashy brightness. So I think we got it licked. So there you have it. Successful repair of a Neotec 2501, or NT-2501 if you want to refer to it as that. This really didn't have anything wrong with it except a shorted blue transistor for the blue color. So after doing all the rework to it and getting it nice and adjusted, and it's good to go. I'm going to let it run for a number of hours to make sure nothing blows up. I'll hook an actual PCB up to it, my Cruisin' USA board that I have. I'll hook that up, make sure it works, and get everything adjusted a bit more for that, and then let it run for a number of hours like I always do, and we'll call this repaired. So, nice, quick, and easy one. Nice to have a quick and easy one after what I went through last time. So, I do have one more for this person. It's a 2515C, so we'll be able to do a standard resolution version of this here coming soon. So another couple of days here, maybe sooner, you might see the third video in this series of 3 for the same person. So if you're interested, stay tuned. Otherwise, thanks for watching. Hopefully you learned something. Like, share, and subscribe. I appreciate it, and we'll see you next time.